Question 3, we've got a reaction going on between ammonia and oxygen. 4 moles of ammonia and 5 moles of oxygen make 4 moles of nitrogen monoxide, NO, and 6 moles of water. We've got some entropy values. Calculate the entropy change for the reaction between ammonia and oxygen. Well, first of all, you need to remember that the entropy change is the sum of the entropy of the products minus the sum of the entropy of the reactants. So what you've got to do is, the entropy change is 4 multiplied 4 NO, so 4 times 211, and then 6 times water is 6 times 189, so it's 4 times 211, add 6 times 189, that's the sum of the entropy of the products. Take away the sum of the entropy of the reactants. The reactants is 4 lots of NH3, 4 times 193, and 5 times 205. So you calculate this, the sum of the entropy of the products, and you take away the sum of the entropy of the reactants, and it equals 181 joules per Kelvin per mole. You know it's in joules because that's in joules per Kelvin per mole, so it's in joules. If it asks for it in kilojoules, you'd have to divide that by 1000, and it would be 0.181. Remember, joules into a higher unit value like kilojoules is a divide by 1000. Calculate a value for Gibbs free energy change, delta G, in kilojoules per mole now, so we are going to have to convert that to 0.181 kilojoules per mole for the reaction between ammonia and oxygen at 600 degrees C. So let's have a look at the equation. Delta G equals delta H minus T delta S. So Gibbs free energy change, delta G, is the enthalpy change. The enthalpy change is minus 905. Take away the temperature. Now the temperature is 600 degrees C, but it needs to be in Kelvin, so you need to add 273 on. So that's 873 here. So it's take away 873, and the 873, the temperature, is multiplied by our entropy change, which is 0.181, because that's in kilojoules per Kelvin per mole. So you need to get that into kilojoules rather than joules. So when you work that out, it equals minus 1063. They allow you anywhere between minus 1063 and minus 1060. The reaction between ammonia and oxygen was carried out at a higher temperature. Explains how this affects the value of delta G. Well, if this is at a higher temperature here, minus T delta S is going to be more negative, or T delta S gets bigger. T delta S gets bigger, so minus T delta S is getting bigger, more negative, and so delta G will be getting more negative. Platinum acts as a heterogeneous catalyst. Heterogeneous means it's in a different phase, it's in a different state. So it's going to be solid, and the ammonia and oxygen are gases. So you've got something that's solid and maybe something that's gases, two different states. And it provides an alternate reaction with a lower activation energy. So what it does is it brings the particles together. So it binds or bonds the particles to its surface. That brings the particles closer together so that they can react, and then it releases them. So the reactants are bonded onto the platinum surface, a process called adsorption. They react on the surface because they're closer together, and then the products are released, a process called desorption from the surface. But you don't need to use those words. You can just say that the reactant bonds onto the platinum surface, they then react, and the products are then released from the surface. Deduce the change in oxidation state of nitrogen when NH3 is oxidized to NO. Well, hydrogen's in +1, and there's 3 of them. There's no charge overall on NH3. So 3 plus 1 is +3, so the nitrogen must be in -3. So the -3 and +3 equals 0 because there's no charge. Oxygen is -2, it's in group 6 of the periodic table, gains 2 electrons, 2 minuses. There's no charge left over, so that's +2. So it goes from -3 to +2. When ammonia reacts with oxygen, nitrous oxide, N2O, can be produced instead of NO. Give an equation for this reaction. So I'll have ammonia and oxygen, making N2O. What else might be formed? Well, I've got some hydrogens and some oxygen, so it's a good bet it's water. and then I've got 2 N's here, so I need 2 NH3s. That makes 6 H's here, so I need 3 H2O's. 1 add 3 is 4 oxygen, so I need 2 O2.